where it puts the values, how to call the operation to add to values off the stack. That's all done by the compiler at the runtime. So move away from the expression of programmers' commands to the hardware into a coding level, to a human level, or the abstract level. Or improve it by making the environment which you work better. So sending units to the room where the mainframe is, with a load of patch leads, asking to program the machine by connecting them together. I'll take a load of punch cards, cut some holes in them to program them. That's like Visual Studio, where you can program in a way which actually helps you do your job. So it makes you more efficient as programmers. Well, that's what the initial programming languages were aimed to do, to make that job easier. Abstract away from the hardware and underlying instruction sets to a common set of instructions for programming. And give a better environment. Anyone just look at basic. We have a simple text editor, type the commands in, compile it, look at error messages, edit it again, compile it again, go through that cycle. Visual Studio can make it better by giving intelligent code insertion, intelligent map of code, can help you as a work in what you're working. The programming language and the principles are still the same in that sense. But a high-level language to express the algorithms, an environment which makes programming itself very efficient. Most programming languages, in the 1950s, we have Fortran and Algol, with any attempts to make programming friendly. Programming Fortran, is not that friendly. I will succeed, but even less so. But they're much better than assembly on machine code. The higher languages, benefits the programmer, you're familiar with, it's easy to understand. So you look like if you have a load on 5, load on 7, add, pop, work out what that's doing, it's intuitive. It's adding two values, adding 5 and 1, simply intuitive from that set of assembly instructions. We'll say programming higher languages, T text plus Y, it's quite intuitive to read, to a point where even programmers can interpret a lot of the content. How can make you more productive? One of the aims is to improve the efficiency, make things cheaper, make software cheaper. One of these things like Algol, Fortran, C, Haskell. Part of all the code was still with my programmer, still compiled to a point where it became the machine code that could then be passed to the CPU to be run. So it's more efficient. It still meant you could do anything to the machine, including quite frequently crash it. The other point to see is that the lack of controls into a C compiler, where you can record lots of problems in a program, which on a standard implementation or standard hardware would run through and just crash a machine. As I say, compiled code, typically you have a similar level equivalent, so push the value onto the stack, push level equivalent machine code version. You're going to spend a lot of time looking at doing machine code or assembler. We'll look a bit into the language machine code as well, language. The key thing is that the kind of instructions of assembler get compiled down to sequences of bits. So hexadecimal, turning it converted to actual bit patterns on the hardware. And so to get rid of the problems of causing machines to crash, we move away from simple compile run environments to ones that have an execution environment. So you write your code at high level, compile it, but it's run not by the machine, but by execution environment. And that's central to modern systems. Again, in the sort of 70s, 80s, early 90s, our Linux operating system. The operating system was the thing that provided the runtime environment for your software. It gave you a richer set of features. So you don't have to rewrite and recreate things like graphical interfaces all the time. Again, Windows, or Windows 1 to some extent, Windows was good, but Windows 3 onwards, big programmers with ready set of graphical interfaces. So you can make a program, compile it for Windows, and it can run in Windows. So as an operating system, it gave you a management environment. It still wasn't completely secure and robust, but it was abstracted away fair from the hardware. days, we've got .NET, Java, a few ones we'll look at. The real intention of the modern mixed-use environment is to have a completely inline system. So you're no longer writing code thinking this is for Intel, RPC, click out if it's a mobile device, whatever the device is, whatever hardware it is, doesn't matter. You write code, you have a language. It's compiled to an execution environment, which itself hides the execution from inline hardware sources. I say a few about older solutions to this, or one of the older solutions, the successful ones, still running a lot of cloud computing, a lot of the systems that we're still using on campus is Unix, usually called CS, Unix, which is later Unix. That's an operating system designed to act as a layer between hardware applications. Again, its success can be seen by the fact it's still common on many mission-critical systems. If you have a robust, reliable system, Unix, or its form, is still a good choice. Again, you see that in the fact that things like Linux, Apple machines nowadays will use that type of Unix operating system as their kernel, or as a model for their kernel. Okay, so that's a simple C program. Well, so that okay?
No, zero-based indexing.
What can happen when you
Depends on the language. Usually you should use everything everywhere.
okay? So once a Unix system will not program, what will happen to a Unix system?
It works.
Could go memory. Everything else happen?
Hopefully compile it quite good.
What with C compilers, they wouldn't quite good. C compilers are written thinking that programmers are supreme beings who will decide exactly what they want to do. And actually, you've got the idea in mind. So they may know that something about that program that one was a compiler writer. So they may want to hold some memory outside of one array because they use an extra array next to it. So C lets you do that because it's allowing programmers full flexibility. But if that does corrupt the system, you have a problem. What was the point of Unix systems? Stability, and you have key features of Unix. Why are they popular on cloud or web servers? Why did they came out in the 70s. Until the last 5 years, Microsoft couldn't even complete the scalability level of Unix. So they had a 10-year gap on development, followed by market dominance in many areas. The Unix was designed for multiple users. So if we're all plugging a Unix machine at once, and I crash it, you'll all be rather annoyed. So it's highly stable, and doesn't, so the idea is it abstracts from what you program from the runtime environment. So if you go to a
Yes, we extend it.
so that's our program. And C compile it. And run it.
Dot slash A.
Sorry?
Dot slash
Dot
A.
slash.
See if we got the execute flag.
Should be extra flags, it's already.
But then again, you've got no output, so why do you expect to see it?
Hmm?
And you've got no output, so why do you expect to see it?
Let's give it one, for example. Well, the first one wasn't wrong, it was, the 100 wasn't outside the dictionary.